Okay, let's get started. We have some more Pythagoras problems, but these are obviously some word problems in here. We have a little situation to kind of read, translate, and draw a right triangle because we can't use Pythagoras without a right triangle. So no one's going to draw the picture for you. You have to read here and be able to translate what's going on. Well, before we get started here, you got to be comfortable with some basic things that maybe we learned in elementary school. Where is north, south, east, or west? Through the years, I have actually seen lots of confusion from students upon what direction is. So north and south go up and down. North is up and south is down here, and this is east and west. So as we do this problem in here, I notice a cyclist bikes 12 miles due west. Well, what does due west mean? Well, that means directly west. So this little line here is symbolizing the direction where the cyclist is traveling. And due west of her house before changing direction. So this was her house, and the bike is traveling, the bicyclist is traveling 12 miles exactly west here. So I don't have to put this arrow, but I just want to tell the story that the bike is traveling in this direction. Then it's going to change direction. Then she travels north, or due north, an additional 16 miles. So I forgot to put the label of 12 miles in here. And now the bicyclist is going exactly due north, or straight north, up to this point right here, 16 miles. And if she bikes home after she's gone 12 miles and 16 miles, what is the most direct path back to her house? So what we're trying to find in this problem is this length right here. This is the length of the most direct path back to her house. And hopefully by going west 12 miles and going north 16 miles, you'll notice that this creates a 90-degree angle. Therefore, this is creating a right triangle. So we can use the relationship of Pythagoras in here to be able to solve for x in here. What do we have? We have 16 squared plus 12 squared equals x squared. Again, why did the x go by itself? Because that is the hypotenuse. So 16 squared is 256. 12 squared is 144. And so what do I have here? I have 256 plus 144. Well, that equals 400. And 400 is equal to x squared. I take the square root of both sides in here. X equals the square root of 400. Well, the square root of 400 can be broken down. In fact, it's a perfect square, come to think of it. What number times itself is 400? Well, it's 20. So this turns out to be a Pythagoras triple. Why? Because all three numbers are whole numbers here. The length of the trip from the last part of her leg of the trip here, when she changed direction the last time and went back home, she would have gone 20 miles back to her house. Now keep in mind, what would be the total distance of her trip? Well, that's another way of asking what is the perimeter of this triangle. And perimeter here refers to the total length of all the sides of the triangle. So if I add up 12 and 16 and 20, notice she went on a pretty long bike ride here, is 48 miles. So how did I get 48? I added 12, 16, and 20. Let's do one more problem, and here we go. Well, in this case, they drew a picture for us, and hopefully you'll see that this is a right triangle in here. So we have an airplane that is 50 kilometers, an airplane is 50 kilometers ground distance from a runway. So even though the plane is flying up above in here, when they talk about ground distance, they're talking about the distance along the ground. That's 50 kilometers. And it's flying at a height of 25 kilometers. So that the distance, when I'm talking about altitude of a plane, that's always the shortest distance to the ground in here. In this case, the shortest distance implies it's a perpendicular relationship, and that creates a right angle, and this right angle is 90 degrees. And so we're trying to find out how far does the plane need to fly to reach the runway. Well, if it was possible for the plane to go exactly at a straight line here right to the runway, we would be able to do that using Pythagoras in here. Well, using Pythagoras, I know one of the legs is 25, the other leg is 50, and the hypotenuse here is x. So 25 squared is 625. 50 squared, I believe, is 2500, and x squared is just x squared. So in this case, I got 2500 plus 625, which is 3125. And now I have to simplify the square root of 3125. So I'm not sure if it's a perfect square. Let me see on my calculator. Well, it's not a perfect square, but I do notice that 25 is a perfect square. Why? Because the square root of 25 is 5. So if I take 3125 and divide it by 25, I notice 125 times 25 is 3,125. So in this case, it looks like the answer is going to be 5 radical 125, but I did not find the largest perfect square that is a factor of 3125. And I know I didn't find the largest one because when I look at the leftover radical here, 125, that can be simplified again. So this is going to be 5, and if I break down 125, that's 25 times 6. So in this case, what do I have? I have 5. That's this 5 right there. I have another 5 right there. That's the square root of 25. And then the square root of 6 can't be simplified. So that's 25 radical 6 is the answer to that distance right there. If I was a little clever in the very beginning here, I would have noticed that the larger one is 625. 3125 divided by 625, that is 625 times 5. This is a larger perfect square than 25. This would have got me the answer a little faster in here. So this turns out to be 25 radical, 625 times 6. Whoops, I screwed up. Hang on here. $31.25 divided by 6. 125 divided by... I'm sorry. I put a 6 here. It's not a 6, it's a 5. Okay, I apologize. Notice 25 times 5 is 125, not 6. Okay, 25 times 6 is 150. So I went a little too fast in there. So notice in here, when we break down 3125, it is 625 times 5, because 625 times 5 is 3125. So that equals 25 radical 5. That's the answer. So let me erase this radical 6 here. That radical 6 is not acceptable. That's 25 radical 5 right there. All right, so a little silly mistake there at the end. Be very careful with your radicals. Hopefully you have still been able to recognize that all the mathematics and the setup is exactly the same. I just had a foolish little error there at the very end. All right.